Hey everyone, I thought today we could focus on liquid measurement with cups, pints, quarts, and gallons. Thought we'd start with a brain pop video first.
Which glass do you think holds more milk, Moby? One glass is tall and skinny, but the other is shorter and wider. What is capacity? Capacity describes the amount a container can hold. Some containers can hold more or less than others. These glasses look different, but they actually hold the same amount of milk. What are cups? A cup is a unit of measurement. Let's see. This recipe calls for 2 cups of flour. We use the abbreviation C to stand for cups. Our cafeteria serves milk in 1-cup containers. What are pints? A pint is larger than a cup. 1 pint is equal to 2 cups. We use the abbreviation PT to stand for pints. Blueberries and ice cream come in pints. Milk can come in pint containers too. What are quarts? A quart is bigger than a pint or a cup. 1 quart is equal to 2 pints. Since 1 pint is equal to 2 cups, 1 quart must be equal to 4 cups. We use the abbreviation QT to stand for quarts. You can get a quart of milk or a quart package of strawberries, and some food containers come in quarts too. What are gallons? You can use gallons to measure larger amounts. A gallon is bigger than a quart. 1 gallon is equal to 4 quarts. The quart gets its name because it's a quarter, or 1/4 of a gallon. It's just like the way a quarter is worth 1/4 of a dollar. Since 1 quart is equal to 2 pints, 1 gallon must be equal to 8 pints. Since 1 pint is equal to 2 cups, 1 gallon must be equal to 16 cups. It's a lot easier to work with 1 gallon instead of 16 cups. You can have a gallon of milk, paint, or water. People can buy gas by the gallon too. We use the abbreviation GAL to stand for gallon. Maybe we didn't measure right. Since there are many ways to measure capacity, it's important to look at the units carefully. I wouldn't eat that if I were you.
Awesome. So there's our brain pop to just get us started on our next activity. So this diagram has always been really helpful to me. It shows you this entire grid right here. It represents a gallon. So thinking about, okay, a quarter of a gallon is 4 cups. So then we have to think, okay, well, if this is 4 cups, then 4, 8, 12, 16. So a total 16 cups you'd have to have in order to make a gallon. Also, the same goes for pints. So we've got 2 pints is a quarter of a gallon. So 2, 4, 6, 8. it would take 8 pints in order to make a gallon. Here you see 2 quarts is half a gallon. So then that means it would take 4 quarts to make a gallon. So our focus today is going to be on dealing just with cups, pints, quarts into a gallon, but our main idea is cups and gallons, so that relationship. So we've got to keep in mind that 4 cups equal a fourth of a gallon, 8 cups would equal a half a gallon, 16 cups would equal a full gallon. So keep that in mind as we go into the next problem. 16 cups equal a full gallon. That's something we need to keep in our mind. 16 cups equal a gallon. So Brendan made 5 gallons of iced tea for his party. How many cups of iced tea can he serve? So we've got to change gallons into cups. So he made 5 gallons, and we've got to figure out how many cups that is. Well, we just talked a second ago that 16 cups are in a gallon. So if you have 5 gallons and there's 16 cups in a gallon, what do you think you need to do there? So right now I want you to try to solve before you continue the video. Okay, so 5 gallons is what he made. There are 16 cups in every gallon. So 5 times 16. Go ahead and solve that now to see if you can figure out how many cups he can make out of 5 gallons of tea. Okay, so 5 into 16. Well, we can always decompose our number using the distributive property of multiplication. So 10 and 6. So 5 times 10 plus 5 times 6. So we have 50 plus 30 equals 80. Not 80 what? That's right, 80 cups. So if he made 5 gallons of tea, then he can serve 80 cups total. Okay, first problem. Let's look at the next one. So the next one says, grades 3, 4, and 5 have their annual field day together. Each grade level is given 16 gallons of water. If there are a total of 350 students, will there be enough water for each student to have 2 cups? Let's read through that one again because that's kind of a big one. Grades 3, 4, and 5, so it's 3 different grades, have their annual field day together. Each grade level is given 16 gallons of water. So you have 3 grade levels, each given 16 gallons. So, okay, if there are a total of 350 students, will there be enough water for each student to have 2 cups? Now, this is a lot, not gonna lie, but I know you can do it. Okay, so right now I want you to write down on your paper, what do you think you need to do in order to solve this problem? It is 3 steps. I'll give you that hint. 3 steps that you'll have to do. Okay, so let's go on over to Ladybug. So the first step we got to think about, okay? So I have 16 gallons per grade level. I said there were 3 grade levels, 3rd grade, 4th grade, and 5th grade. It's just like we would do fun and field day at school because we do have all those together. Or technically, no, we do 2nd, 3rd, and 4th. So same difference, 3 grade levels. So 3 grade levels, each grade level gets 16 gallons, okay? So 3 times 16, well, we just did this was 5 times 16. So 3 times 16, 10 and 6. So we could do 3 times 10 plus 3 times 6. So we've got 30 plus 18 gets us 48. 48 what? 48 gallons, that's right. Okay, and if you're doing an awesome job and you're up to partial product, so remember we could do 3 times 10 and 3 times 6 for the same setup, so 30 and 18 to get 48. Okay, so we now know between the 3 grade levels, 3rd grade, 4th grade, and 5th grade, that we have 48 gallons of water. Okay, now they're wanting to know we have 350 kids. Is that going to be enough to give every one of those kids 2 cups of water? Well, we got to go back to our grid and think, okay, there's 16 cups per gallon and we have 48 gallons. Now what are we going to do? So think about that. See if you can figure it out. Pause the video. If not, here we go. We've got 48 gallons times 16 cups because each one of these gallons holds 16 cups in it. So now we've got to figure out, and that's going to get us what variable do you think? That's going to get us C. That's going to get us a total number of cups for all of those 48 gallons. That's a lot. So we've got to figure out what to do. So 48 times 16, we could revisit the area model. So 48 and 16. Okay, so one piece at a time. 40 times 10, 10 groups of 40, 400. 40 times 6, 6 groups of 40, 240. 10 groups of 8, 80. 6 groups of 8, 48. So now we've got 400, 240, 80, and 48. So I see 8. I see 8 here and 8 here, so it's 16. Carry the 1, 6, 7. 768 cups. 768 cups is what we have. Well, that's great. That sounds like enough because I know when I think about this, 350 kids plus 350 kids because they each get 2 cups. So I've got 600 plus 50 plus 50, that's another 100. So I've got 700 and I've got 768. So I should have actually a little bit extra. So we've got to figure that one out. So we've got to take our 768 cups, divide it by the number of students to figure out how many total cups that's going to get us. Because that's what we want to know. We're going to have enough cups to get for each student. Total number of cups for each student. That's what we're going to try to figure it out. Now, this is a big one. We haven't really done a 3-digit divided by a 3-digit, but I know you can knock it out. So 768 is our dividend. 350 is our divisor. So already said 350 plus 350 was 700, and that's pretty close. So times 2. So that got us to 700. Now we've got 68. So do we have enough for every kid to get 2 cups of water? Because I know 350 will not go into 68. So that means I have 68 cups of water left over after everyone gets 2 cups. Maybe those cups can be left over for the teachers and the helpers. Okay, so yes, absolutely, we can solve this problem. That the original problem was, if we go back to it, will there be enough water for each student to have 2 cups? Yes, there will be enough left for 2 cups with 68 cups remaining. Awesome. I hope you enjoyed this number talk. Have a great day.